Okay, I am going to try to show people how to build the plasma balls as I build them. I buy my plasma balls from Walmart. They cost roughly $25. And I buy a few accessory parts, obviously. And there's a lot of labor that goes into it. But the project is relatively easy to do, least-wise it is for me. Especially once I figured everything out, it just made it a piece of cake. Okay, so we're going to start off with plasma ball comes fully assembled, obviously. I've already separated the top. This happens to be a 5-inch globe. The ones I buy from Walmart are 7-inch globes. It doesn't really make a lot of difference. Globe size, this is going to work just as well as if I had the 7-inch globe. Actually, I think the 7-inch globe looks a little nicer. I'm only using this right now because it was convenient, and it's smaller, and I've got a rather crowded area here. So I took them apart. There was 4 screws at the bottom of the base that I took out. I separated them, and this is what the board looks like. And the very first thing I do is I take the board off the plastic housing, and that's pretty easy to do. It's just a couple of clips here. They sort of bend backwards, and then the board pops right out. So I have a board here that's fully assembled, and it will work. In fact, it's a good idea. You test everything before you start chopping things up. So I'm going to plug in the power. The power is now plugged in, and I'm going to turn it on. There's several ways you can test to see if it's really working. I happen to have a meter, and I happen to have a scope. And what's actually better than the meter is a little mini scope I bought. You can find them on the website. This is a DS202. It's not the best scope in the world, but it makes a great electric field tester, and I'll demonstrate that. First, I'll demonstrate the plasma ball with it actually being in the circuit. And I'll turn it on, and there you go. You can see the plasma balls firing up just fine. By the way, the plasma ball didn't come with a fan. It didn't come with the switches either. This has already been modified a little bit, this case. At any rate, but the plasma ball works just fine. You want to check your plasma balls before you chop up your circuit, because if there's something wrong with your design or modification and the plasma ball was broken to begin with, you're not going to know what the story is. You're going to be confused. Okay, so at any rate, we know that the plasma ball's good. We know that the circuit board's good as it is. Let's start chopping it up and modifying it. So the first thing I do is, like I said, I separate it from the plasma ball, unplug the power supply, and here is the basic board. And the very first thing I do is I take off a bunch of components. Here is the board with the components off. I just unsoldered them. Here's the back of the board. I just unsoldered the components. There's 15 components that I take off. You don't have to take off anything except the transistors and a resistor or two, but I'm not going to go into that detail. You can, I'll put this on the website with a picture, and I'll say remove, or I'll put an X over the components, and these components are labeled on the board. So there will be a picture that will go along with this that will show you exactly what components I took off. The reason why I take the components off is because it makes the board less cluttered and easier to work with. Half the components were used to drive a little circuit for sound detection. I removed the sound detection completely. The only thing I want is the onboard oscillator, which is generated by this chip here that I'm pointing to with my finger. This looks like a 14-pin chip, dip chip. And these other components are required to get power to the chip, and a little RC oscillator circuit in there, and a little filter. That's what the cap is here for the incoming power supply. So that's what I do first. Or second, I take the part out and I strip it from the essential components. The next thing I do is I mount this little guy. This little guy is universal serial, universal, not serial, universal, what do I want to call it? I'll call it the driver board. In fact, I have a print, which is also on the internet, and it is, here's a print. You can find this on the internet, and it's called the Universal 12-volt plasma ball controller. This is all you need to convert, after you strip some parts, to convert a plasma ball into a controllable plasma ball that can be controlled by a spooky or any other function generator. It'll provide 2 channels of control, and the 2 channels have slightly different functions, which will be covered in a different video. This is sort of like how to put it together. If you go into the website and download this page, I'm going to go over this little board real quick. There's a plus voltage, which I happen to label or color with a red wire. A ground, which I happen to use a black wire for. And I have an output trigger that will actually go and drive the plasma ball and circuitry, and that happens to be blue. I have a white wire, which happens to be what I call channel 2 for the spooky or gating channel, and I have the yellow wire, which I call the primary or channel 1 for the spooky. And these 2 wires right here, they connect to the plugs on the case I make. They run through a switch. There's a couple of extra components that actually get wired to the switches. But these 2 wires here, the yellow and white, end up going to the plasma ball switches internally. When that's all done, I have a circuit like this. And now you can see there's a little universal plasma ball controller, and it's sitting in an area where I got rid of the transistors. I used to just get rid of the transistors and a resistor or 2, but now I get rid of all the components that actually aren't necessary. And it makes it very easy for the little universal controller board to sort of tuck up inside on top. And I make sure that the bottom of this board with all its solder connections is not going to touch any of the components or anything else. And I put a little insulator. This is fanned insulation material, and rather fluffy. Actually, a filter fan is what I should have said. It's a filter, a very thin filter. I buy it in sheets, and then I cut it into strips. Here's some strip that is left. Oh, here's a sheet. Okay, reaching over. Here's a sheet that I bought, and you can buy this at Walmart. You can hunt around for it. You can buy it off the internet. And I just cut a little square pad and put it underneath there. The plasma ball will be mounted inside, and will never. This will never get moved once this board is fixtured inside the casing. So I don't worry about things shifting or anything like that. And let's go over the connections. So the connections, the black wire right here on this side happens to go into the ground. That happens to be the ground, pointing to a ground land. This thing here, right here, that's a ground land. And I took out the little microphone that was a sound detector, and it gave me a little hole to connect for ground. And there we go. So I connect the black wire there, and I connect the red wire to this bus right here. I'm rubbing my finger across it, and you can see that here's the socket, and you can see the back end of the socket, which is the positive. You'll see the solder joint, and you'll see the length of this, and that's all positive voltage, and that's where I plugged the red wire into, and I soldered, of course. The blue wire right here the blue wire. It loops into the board, and the picture that I'm going to put on the internet will show you exactly where I put this blue wire. And I have it presently right now on this board. I have it going into Q3, and I have it going into what used to be Q3's base connector. Okay, there used to be a transistor there. I removed the transistor. And that's where the blue wire goes. And I'm going to point something out here. The blue wire goes right there, where I'm pointing that little black, and it runs in that LAN here, that big square or rectangular square pad is the driving circuit for the power transistor that actually turns on and off and energizes this transformer that I'm pointing to. And of course you get a high voltage going up here, and it goes inside the plasma ball and ionizes the plasma ball and creates Birkeland currents. So in the end, after this board has been peeled down, 15 parts were removed, and then this little universal board was mounted on top. I have two wires coming out. Now you notice that there's this orange wire. This orange wire connects to the output of the internal oscillator that's generated and came with the board. I stripped everything away except left the internal oscillator, and this board here is sort of, this wire here is sort of like the default setting. When I have the plasma ball with the switches down, both switches down, this plasma ball runs just like it came out of the box. It ignores everything that's in the box, and it runs just like it came out of the box. And it does that because I pump the output of the oscillator into the yellow wire through the switches. I hope this is making sense to those who are technically inclined. I connect those two. I'm going to demonstrate this, by the way. And this will run the plasma. It will fire the transistor and everything coming from the oscillator here and turning on and off, and then energizing the transformer and creating a very high voltage, about 20,000 volts plus. I don't know what it is exactly, but it's up there. And that is the essence of a modified plasma ball. These two inputs, I already said, the yellow and the white, they get connected to the spooky. I have a spooky right here, channel 1 and 2. But this yellow wire, through a toggle switch, is either connected to the spooky channel 1 or connected to the internal oscillator. So we have a default position, so to speak. Okay, looks like I've got everything in the video there. I didn't move around too much. So the key is to look on the internet, copy and download these pages. There'll be a page of both sides of this board, maybe a couple of pages, and I'll show you what components are removed, and I'll also show you, mark where the universal controller board connects to. And the reason why I designed a universal controller board, where's that? There it is right here, it was just too much work chopping up. I used to chop up the board and jumpers all over the place. Here's a picture of the very original, same circuitry. Left a lot of things on. It was just a lot of work. I was cutting lands. I was doing this and that. Now, with this little board, I don't have to cut any lands to make it work. I am going to cut a land, but I haven't got there yet. I'm going to cut a land to protect the transistor from getting too hot. I'm going to put a mechanical thermistor in there, but that's a little bit later down the road. If you don't put the thermistor in, the unit's going to work fine. You just have to know what you're doing so you don't cook your transistor. So at any rate, there's a circuit, and there are all the inputs. Channel 2 represents the spooky channel 2, and it goes into, there's the word white, so it's saying it's going into a white wire. There's a blue wire somewhere. Where's a blue wire? A blue wire to the base connector. Base connector, I'm referring to the base of the driving transistor. And there's a black wire and a yellow wire and so forth. It's right here. You have a circuit all drawn out for you. The circuit is real simple. It's got 2 transistors, 6 resistors, and this is optional. This was a mod that I put on at the end, probably about almost a year ago. I had plasma balls out there without this. And then about a year ago, I put in a 5.1 Zener diode to help prevent over voltage. The spooky can be dialed all the way up to 20 volts. You don't use a spooky boost with the plasma ball, but it only really wants to see 5 and 10 volts. It wants to see 5 volts on channel 1, and it wants to see 10 volts on the white wire. And the spooky can dial that up real nice. But some people were saying, well, gee, if I put a spooky boost down there, I can get 40 volts into channel 1. Won't that be much more powerful? No. This is TTL logic. It only wants to see 5 volts. Put too much voltage in there, and you will definitely pop the transistors on the universal controller board. And in the end, you could pop the driving transistor on the plasma ball. So enough said about that. I'm going to put this away. Just a little, this is also on the internet. This was the old 3-inch plasma ball I used to design, but the circuit concept is identical to what we're doing here. I have a driving transistor, and you can download this. There's the driving transistor, and the driving transistor is turned on and off through a resistor. This diode is not necessary on this circuit. This is, in fact, you could just remove that. This is a transformer. And what you're doing is you're turning on and off the transistor and providing voltage to the main coil of this little block here, this little transformer. And this transformer is turning around and creating a high voltage pulse out of this, we'll just call it the high voltage lead, output lead. That's the basics of a plasma ball circuit. They all work very similarly. The only differences might be components. Some are driven with a transistor, some are driven with a MOSFET, but they're all basically just turning on and off a voltage to a high voltage transformer. This was a channel 2, and I had to go chop up the plasma ball quite a lot, and at any rate, there's an example of the transformer, by the way. This block here is drawn in a pictorial transformer picture here. Okay, for those who are technical, you have now all you need, except you don't have the universal controller board. Right now, I am not selling anything, even though I'm building a whole bunch of balls and I'm building a lot of product. I'm not selling anything. Please understand that I'm a one-person shop. I have a helper, but the helper doesn't help in a lot of areas, and I'm just working too much. So I'm taking a break. I'm also having a little problem getting components because of this COVID-19. So let's do a little demonstration and talk a little bit more. How long is this video? This video is 18 minutes long. Hopefully I can get this whole thing done in another 5 minutes or so. All right, so I have a circuit that is absolutely up and running. I'm going to get these other lights out of the way. I normally put a heat sink on the transistor. That transistor gets rather hot. And that's why in the case I added a fan and vent holes, fan, to help keep things cool. The plasma ball board, I had already pointed this out. I'll use this wire right here. I'll use a black, wherever I put it. Here it is. Use my black pointer. Hopefully you'll see this a little bit better. This area right here is a 12-volt bus. There's one hole there that had no components in it, and I plugged the red wire from the fan into that hole, solder it, and then I plugged the black wire into this hole pretty close to the transistor, which is also ground and had nothing in it. Normally these things are filled up with solder, so when I'm unsoldering, I solder suck these holes clean. So I haven't drilled anything. I haven't cut any lands, and I could put together a plasma ball without making any mods on the circuit board itself. but I am going to make a mod. I not only put a heat sink, but this heat sink has a thermistor, a mechanical thermistor, heat glued. There's heat paste out there that actually acts as a glue too. And it's actually glued to the heat sink, and it's got 2 leads on it. And what I normally do is I cut a land. And I'm going to have this on the print, so if you had downloaded and printed the print, you'd be caught up with me right away. This is the 3 leads for the transistor, the driving transistor that turns the transformer on and off. This land right here that I'm going up and down, this long one here, comes from the transformer. I cut a little slot in that, and I put this thermistor. Now I actually have to drill a hole. I drill a hole so I can poke one wire of the thermistor so it's connected to the transformer, and the wire the land has a break in it. And now the current goes through the thermistor and comes out the thermistor, and there's a hole already right here just waiting for me to use on this. And so I put the other wire of the thermistor to this hole right here. I added a hole here and separated. And now if this thing gets too hot, the mechanical thermistor will open up and stop driving the transistor and let things cool down. And it works pretty well, but you can still blow everything if you abuse and not understand what you're doing when you're driving this converted $25 toy into a real health modality tool. That's another story. A lot of people say, oh, it's just a toy, you're not doing anything. I'll tell you what, this toy is more powerful than the $17,000 Spooky Central in some ways. It's not as powerful overall, but in some ways it's more powerful. And the reason why is because it generates its plasma with Birkeling currents. Birkeling currents is how the universe is connected. That's another video or another story to talk about. It's amazing, and there are a lot of other things besides just a $25 plasma ball that can be converted to a health modality tool. But this happens to be one of the most powerful in my toolbox of delivery devices. I have nothing that works better than this. It works better than the hand grips. It works better than anything that works better than the spooky remotes. It's just a great, inexpensive delivery device. And anybody who says it isn't, they're either jealous or they're trying to sell you something different. I'm not trying to sell these for profit. I'm trying to sell these to help people. I'm not actually trying to sell them. I'm building them to help people. But I have a limit on how much I'm going to work, and hence I'm taking a break. But of course, I think I already said I'm having a little difficulty getting parts too. So, and I really appreciate this break. Meanwhile, I'll stock up and build components. So you can't buy any of this from me right away, and you won't be able to buy the universal board. Simple circuit. Also, oops, I didn't show you this. On the internet is this is the mass. This is the circuit board itself, blown up a little bit because I have the circuit board made by a West Coast company. I provide them with the mask, and they send me back a board with the etchings on it, and then I cut it up, and I get 1, 2, 3, 1, 2, 3, 4. I get 12 boards out of a single board because it's so tiny. But you have the circuit connection layout, so you could copy this on a breadboard and just run wires where these lamp patterns are. Okay. Well, if that doesn't make things simple for you, here is a unit that has had, here you can see, there it is. You can see I stripped out a lot of the components. There's the controller board. And there's the heat sink with the thermistor wires connected. On the back of this board, where's my pointer? Here's my pointer. Right there, you can see where I cut a land. Actually, I drilled the hole, pull-through hole on the wrong side. And I says, oh, what are you doing? So I drilled it on the right side. You can see where I cut the liam, broke the liam that goes to the base of this transistor, and I intercepted it with the 2 wires from the thermistor. So if that gets too, and it's normally closed. It's a normally closed thermistor. It gets too hot, it opens up. And it breaks the connection, stops the drive to the transistor, and saves the transistor. Okay. I hope that is enough to help a lot of people out from the technical standpoint. I'm going to wind this up. This video is 25 minutes long, way longer than I thought. I'm going to do another video on operating the plasma ball with a spooky and talking about it and telling about the things that so many people called me up and asked, how do you do this? How do you do that? Well, I'm going to finally do a video on it. I haven't done a video, believe it or not, for 1.5 years on this plasma ball, and you're going to find this hard to believe. Every time I do a video, I get overwhelming emails and requests to order. And I can barely keep up with what I got now. I've got over 100 plasma balls out there now, and it took almost 2 years to do that. And I'm doing other projects on top of this. So, okay, that's my story. I'm sticking to it. I hope this video works, and have a very nice day. Bye-bye, everybody.